I was worried about Dane and Andre together. I guess I need to be worried about Josh and Dane. Jeepers. That is the common link here. Okay, you don't need to write this down, but this is what we are going to do. We are going to talk about parametric and symmetric equations for a line in 3 dimensions. Okay. We're going to talk about the relationships between lines and space. And then we're going to talk about planes, the general and standard form of a plane. We're even going to sketch a plane. Okay. And find the intersection of 2 planes. Hey, 2 planes intersect and they form a
accident
line. What did you say?
Accident. Casualties.
Okay, do we have 3-dimensional slope? How did we prove that 3 lines were collinear? We used what? This was on your quiz. It was. There's 3 points. They're collinear if you form 2 vectors and the vectors are parallel. Okay, so we don't have 3-dimensional slope. We have a vector that can tell us the direction of where our line is going. Okay, so typically in 2 dimensions, you have your slope, you have your point, you can create a line. Okay, well, in 3 dimensions, we don't have slope like rise over run, but what we have is a direction vector that can tell us where our line or what our line would be parallel to. Okay, so you see this red line right here. Okay, here is a vector in standard position that is parallel to this red line. So we're going to use this direction vector and a point on this red line to actually write the equation of the line. Okay, I'm going to talk a lot before you even need to write something down. Okay. So since we want a parallel vector, right? Let's come back to here. Here's our vector. We're parallel to the line. We know that if we have parallel vectors, the vectors are scalar multiples of each other. Okay, so to determine the equation passing through the point P, parallel to vector V, we're going to use our knowledge that we have scalar multiples. So if we have the vector through P and any other point Q, then we know that PQ has to be some scalar multiple of our vector V. Okay, so PQ is on the line. Okay, so if this is the case, then I can distribute that T through, right? That's how we get AT, BT, CT. Sounds weird. When we have a vector, we take terminal minus initial, terminal minus initial, terminal minus initial, right? Okay, so now look what we have. X minus X naught is the same as AT. Y minus Y naught is the same as BT. Okay, so when we actually set those equal to each other, this is what you need to write down. This right here. These are what we call the parametric equations for our 3-dimensional line. Gonna read before during practice.
It's supposed to start at like 4 or 5.
so warm out. Cold rain is the worst. Was it raining when you guys played Thursday in Lexington? Yeah. Well, that's what it was like here, but I don't know how that. Yeah. That was fun. There lots of slipping and sliding. No. When grass gets wet, doesn't it get slippery? Yeah. Okay. Okay, now notice, since we set up parametric equations, these all have t, right? So if we solve this guy for t, we could subtract over the x naught and divide by a. If we solve this guy for t, we could subtract over the y naught, divide by b, et cetera, and they all would equal t, correct? So here is what we call the symmetric equations. Basically, it's just a different version of what we have up here, our parametric equations. Okay. Now, let's talk about that x naught, y naught, z naught. That's a point that's actually on your line, okay? And then the a, b, c, that's the parallel vector, okay? So if you know a vector, your direction vector, and you know a point on your line, we can set either one of these set of equations up. Okay. Okay, so this is just like basically summarizing what I just said. A line passes through the point P, so that's your x naught, y naught, z naught, parallel to vector V, A, B, C. We take that information and fill these in, whether it be the parametric equations or the symmetric equations, okay? How does this help? If we plug a number in for t, we get an x, y, z coordinate, okay? We don't have just like one equation because we have 3 dimensions. We have to write them separately. Okay, so here we go. Go ahead and write down example. We're going to find the parametric and symmetric equations of the line passing through the point 2, 3, -4, parallel to the vector -1, 2, 5. Write down what you need to. Evie, is your game here?
No, it's a reversal.
Gotcha. At 7?
Yeah.
You really get to play in the rain. All right, so x, we're going to take the x coordinate 2 and add at. Y. Oh, okay. We're going to take the y coordinate 3 and add bt. Z, we're going to take the z coordinate -4 and add ct. And here is our set of parametric equations for the line passing through this point parallel to this vector. I feel about that. You don't care. Okay. Now, we can plug like 0 in for t, and we have the point 2, 3, -4. We can plug 1 in for t and have the coordinate 1, 5, 1. Okay, and we can find basically a bunch of coordinates, just like we would be able to do for like y = 7x + 3, right? Just graphing it's a little bit different. Okay, now for our symmetric equations, all we have to do is think about solving for t in each one of these. So subtract over the 2 and divide by the -1. Subtract over the 3, divide by 2. Add the 4, divide by 5. Set of symmetric equations. Well, this problem was nice because everything was given to us, right? Okay, it'd be like me giving you, here's the point, here's the slope, and it takes you what, 2 seconds to write the equation of the line. Okay, so let's see. A line that goes through 2 points, go ahead and write it down. What are you studying?
Psychology.
I really like it. And it's, red goalie here. That's
So I
what
think
it's- these are nice. That is important, especially for like a day like today. Or tomorrow. Oh, so today, not so much. But if you're playing like tomorrow or Wednesday, it's not supposed to be real nice the next few days. Okay, so what are we gonna do if we have 2 points? What do we need? We need a vector. How do we get a parallel vector? Take these and make a vector. Does it matter which one is your initial, which one's your terminal? No, our equations just might look a little bit different, okay? In one direction, well, whether you do PQ or QP, they're just gonna be opposite, okay? But we're still gonna get the same line, okay? So let's just treat this one as terminal, this one as initial. Our vector would be what? Great. Or just do all the work for you, make sure you agree with it. Okay, now, does it matter what point we pick to use? It doesn't. What's gonna happen though, is if I pick 1, 2, -2, and Josh picks 3, -2, 5, our equations are going to look different, but will represent the same line, okay? So I'm gonna have to be patient when I grade, and I'll have to really like look through your work. Not everybody's equations are gonna look the same, okay? So how about you go ahead and pick this first coordinate. Here's your vector. Please write me the 3 parametric equations for this line. Check in with your neighbor, see if they have the same thing. read that very quickly. I hope I got it all. Do you agree with Dane? Okay, now, if we would have chosen the other coordinate, we would have had x equals 3 plus 2t, y equals -2 minus 4t, and z equals 5 plus 7t. Obviously, those don't look the same. And when we plug in t equals 0, t equals 1, we're not going to get the same coordinates. However, I haven't really thought about this, so hold on. So if I plug in 0 here for t, but 1 up here for t, we're going to get the same coordinates. Okay, so the t values are going to be different, but still when we plug in certain integers, we're going to get the same coordinates on that line. Okay, they're just set up as a little bit different. Okay. So take what you have in blue and go ahead and write the symmetric equations for the blue set. And then check in with your neighbor. You can totally like talk to each other too. Like you don't have to just like whisper or like talk with your eyes. I couldn't tell what that was back here. Or socks. Okay. Andre, symmetric equations. Thank you. Okay, so that is how we write the equations of lines in space. How many points does it take to make a line? How many points does it take to create one unique line? 2. How about smart aleck? How about a plane? 3 points to create a plane. Okay, so don't write this yet. Okay, so here I have point P in our plane, and N is the normal vector. Ooh, what does normal mean? Yes. Okay, so this is perpendicular, and let's just make Q X, Y, Z. Okay, so PQ terminal minus initial would be X minus X naught, Y minus Y naught, Z minus Z naught. Okay, if N, aka the vector ABC, is perpendicular to the plane, what do we know about these two vectors? Which means? Yes, they're done. Well, it's just not what I want. You're not wrong. I'm just like trying to fish for more. Thank you, Grace fam. Their dot product is 0. So if I take the dot product of N and PQ, then we have A times X minus X naught, B times Y minus Y naught, C times Z minus Z naught. And when we do that, it should equal 0. Dun, 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 dun. Here is the standard form a plane. Where ABC is our normal vector and x naught, y naught, z naught is a point in the plane. Please make sure you make a note of that your vector ABC is your normal vector and x naught, y naught, z naught is a point in the plane. Okay, now if we distribute the A, distribute the B, distribute the C, and combine like terms, then we have the general form, AX plus BY plus CZ plus some constant D that would come from when you distributed and combine like terms. Okay, so this would be the standard form, and then if we distribute it and combine, then we have the general form. Where's Friday? Indoor. All right, so let's do an example. We have a normal vector of 3, 1, -2, and a point in the plane 2, 3, -1. Write that down, then we'll go through it together. So for our standard form, we're going to take our vector, take 3, 1, -2. 3 gets multiplied to x minus x, plus 1 gets multiplied to y minus y, plus z gets multiplied, or -2 gets multiplied to z minus z. And that equals 0. When we formed this, we were taking the dot product of 2 orthogonal vectors. So this would be our standard form. If we want our general form, then we're going to have to do a little bit of algebra. We can take the 3 and distribute it. Distribute the 1, distribute the -2, and then combine like terms. So we have 3x plus y minus 2z minus 1 equals 0. All right. You told me that it takes 1, 2, 3 points to define a plane. So here I have 3 points that define a plane. Find the equation of a plane in general form, but I have 3 points. I don't have a perpendicular vector. Yeah, that is too bad. If only there was a way. If only there was a way to create a perpendicular vector.
That one, wasn't that like the last question on our quiz that no one got?
How do you create the cross product, people? If you take the cross product of 2 vectors, you get a perpendicular vector. You remember that? Nope, obviously not. Okay, so let's create 2 vectors from these points. So like, let's create a vector out of these 2. What would we get? 3, -2, 4. Terminal minus initial. Terminal minus initial.
I was like, how do you?
No. Okay, so then let's, oh, what am I doing? Sorry. Now let's take those 2. And our vector would be 1, -3, 6. So let's just say that's vector u, vector v. Now let's take u cross v. Is this coming back? Just a little bit. All right, so we get -12i plus 4j minus 9k minus the quantity -2k minus 12i plus 18j. Oh man, what happens to the i's? They're gone. So we have 0i. What about our j's? And a 14j and k. Okay, so there is our normal vector. When we take the cross product of 2 vectors, the result is orthogonal to both. So here is our vector. Does it matter which coordinate we pick from up here? No, it doesn't. Which one would you like to pick? 403. We're gonna pick this one. All right. So we have 0 times x minus 4 plus 0 times, nope, plus -14 times y minus 0 plus -7 times z minus 3 equals 0. Now, whether we set this up with this vector and 403, this vector and 1, 2, -1, maybe you get the vector 0, +14, +7, and you choose it. It doesn't matter what's going to happen. when we go and find the general form, it's gonna be the same no matter what. Okay, so this is gonna be, the x's go away. Negative 14y minus 7z plus 21, right? Okay, we can make that look prettier, can't we? I'm gonna write this as 2y plus z minus 3 equals 0. What did I do? Divided by negative 7. If you left it like this, am I gonna care? No, but this is probably what Calc Chat's gonna do. Okay, I'm gonna skip over sketching planes because I think that's the least important. Let's talk about the intersection of two planes, and that'll be how we end our day. Okay? Don't be so excited, Andre. I think that means Andre wants to learn more, right? Stay past 225. That was that one. Okay. So if two planes intersect, as long as they're not parallel planes, they're going to intersect in a line. Okay. So I want to find where these two planes intersect. So go ahead and write them down. Okay, so if we know that the intersection is going to be a line, we know our answer needs to be a set of parametric equations that represent a line. What do you suppose we need to do? Eliminate a variable? That sounds great. Which variable would be nice to eliminate? Okay, so it doesn't matter. All right, we can eliminate y. So the y's are already opposite, so we didn't actually have to do any algebra. If we wanted to eliminate x, we could multiply one of the equations by -1, but it's not going to matter. We are left with 2x plus 6z equals 0. Okay, or 6z equals 2x, aka z equals 1/3 x. What? Oh, negative. There's a negative. Sorry. I was feeling positive today. I know that's hard for you to understand. My negative Nancy's in here. You're one of the most negative in this room, sir.
My mother's name is
He said there might be some.
No, he's going back to his word. I asked him on Sunday, he said it.
We're supposed to get snow?
It was like, there was a chance there's snow.
I don't.
Like, there might be a chance, and then it's Sunday.
So this is what we're gonna do, people. We are gonna say, all right, x is t, so z is -1/3 t. Do you see what I did there? I gotta make a set of parametric equations, so I'm gonna say x equals t, so that z is -1/3 t. Well, now we need y. How do we get y? No. Now we can go back to either one. Okay, if X is T and Z is -1/3 T, now we can solve for what Y is in terms of T. Right? Maybe? What are you getting? What? Positive though, right? 1/9 T. And there's our set of parametric equations. Okay, do your homework. We only have one section left that will probably break up into 2 days, but we'll see how tomorrow goes. Okay.